Hi everyone, and welcome back to Fundamentals of Engineering with Farhad. Mechanics of materials, maximum deflection calculation in beam, solution 2 in a fixed support beam with a concentrated load of P at its center. So we have solved this problem with the help of the moment area method in solution 1, and now we want to solve this problem with far simpler approach, which is combined method. So by applying the combine method, if we just consider half of the beam and apply half of the load for the first part and the other half for the other part, so half of the load comes for this part, and using a sliding support at the center, and then by creating the symmetrical axis for our asymmetric loading. As you can see here, the beam deflects like what you can see here, and we do know that the moment is also zero. We'll talk about it in next videos about what happens to a symmetric loading at the intersection of the beam with the symmetrical axis. So if m is 0, and you can easily see half of delta is here and the other half is on the other part. So if we call this part delta over 2, and because m is here, we can shift this force at the quarter of L. So it just says our shape will change to a cantilever beam with the length of L over 4 and a load of P over 2. So the deflection for a cantilever beam with the load of P and the so for example, if we want to, if you remember such a beam like a cantilever beam which handles a concentrated load of P at its free end, and you want to calculate the deflection, you can easily see that deflection delta maximum is equal to delta max is equal to PL cubed over 3EI. The same approach here applies, but this time for delta over 2, P over 2, and now L over 2. Delta over 2, that's because that's for due to the previous part, and it just says delta over 2 is equal to P over 2 times, in parentheses, a quarter of L cubed over 3EI. And if you do the mass, and also delta maximum is the 2i's of delta over 2, that's the obvious. And if you do the mass, it just gives you PL cubed over 192 EI. If you remember, we have solved it with a more elaboration in moment area method, and it's far simpler in combined method. And if you have a fixed support and a concentrated load at its center, delta maximum is PL cubed over 192 EI. Thank you. We'll solve more problems in beam in next videos.